All right, real quickly. If you take a look at that first example I have for you. Any GCF, n squared minus 64. Any GCF? Okay, shoot. All right, let's go down our list here. There's no GCF. How many terms are there? Whoa. Whoa. It's not a trinomial. It's a binomial, right? Have I, other than taking out a GCF, have I ever asked you to factor a binomial? No. No chance grouping is going to happen because how many terms are there? 2. We usually need 4, and I can tell you we're not going to turn 2 into 4 like we turned 3 into 4, right? That's not going to happen. So we're kind of stuck here, aren't we? Shoot. We're stuck. All right, I want to remind you of some of the work we did when we first met after the midterm. Do you remember multiplying those two, where the sign just changed? What happened to the middle term? They canceled out, right? The two middle terms, and you were just left with x squared minus 36. That's where we're going today. We're going to go backwards now. Okay? Before we do that, though, you guys missed a unit, all right, before the midterm. Not to your fault, all right, that I still have to do with you, all right? But let me write some numbers up here and see if they look familiar to you. Do any of these numbers look familiar to you? And I wouldn't blame you if they didn't because you haven't been there yet. Emma, they're called perfect squares, okay? 9 is a perfect square of 3. 49 is a perfect square of 7. 100 for 10, okay? So are some of us familiar with these perfect squares? Because that's what you're going to see today. The numbers on there will be perfect squares. All right, you know the numbers. Let's talk variables that are perfect squares. Let me just write up a bunch of them and you tell me what they all have in common. All right? What do all these variables are perfect squares I wrote up here. What do you all notice about their exponents? They're even. Any variable that has an even exponent is a perfect square. This is a perfect square for x. This is a perfect square for y to the 4th. This is a perfect square, any guesses? B to the 15th. What are you guys doing to the exponent to find its perfect square? Dividing it by 2. Okay? So let's go back to that first problem we had, n squared minus 64. Ready? Watch. What do you know about n squared? It's an even exponent, which makes it a perfect square. What do you know about 64? Perfect square. So this process right now is called the difference. Why difference? You're subtracting. The difference, because you're subtracting of 2, what are these called again? Perfect squares. All right? I usually refer to this as the old DOPS method. Anybody know why? Distribution. Difference of perfect squares. Some other teachers do dots. I like DOPS. All right, that's how I roll. Difference of perfect squares. All right, so we've identified subtraction, perfect squares. N squared is a perfect square for, so n and n. 64 is a perfect square for 8 and 8. And you guys know from when we did multiplication, if I have no middle term, what do you know about the signs? They're always opposite each other. In difference of 2 perfect squares. It does not matter which one comes first and second, just as long as the signs are opposite. All right? All good. All right. Well, you look at 2, and you're like, whoa, 50, that's not a perfect square. Either is 72. You already forgot where you came from. What do I always ask you to look for first? Darn right. Find a GCF for 50 and 72. Yeah, I know they're not perfect squares, but find a GCF always first. Biggest number that goes into 50 and 72. Don't yell anything out. I'll ask somebody in a second. You won't have to go too far to find it. Biggest number that goes into 50 and 72. Again, you won't have to do too much work to find it. Did we find that GCF? All right, looks like I'm just going to have to ask you guys. Numbers aren't working today. What number did you find? 2. So let's take out a 2 first and watch the magic that's about to happen. You take out a 2, 2 into 50. Oh, what is it? Oh, what do we know about 25? Oh, all right. Did we touch the a squared? Perfect square. Minus 2 into 72. 36, which is also a. Okay, so what is inside this parenthesis right now? Difference of perfect squares. So let's see if we can factor it one more time. Keep bringing down the 2. Take your time. For 25, it's a perfect square of 5 and 5. What about a squared? It's a perfect square for a and a. And what about 36? 6 and 6. And if we're doing this method, the signs always have to be opposite each other. Plus, minus. Look for that GCF first. All right, let's roll through some of these now. X squared minus 81. Any GCF? Nope. What do you know about x squared and 81? Perfect squares. So x and x. Perfect. What's the square for 81? 9 and 9. Signs are always opposite each other. Plus, minus. M squared minus a 100. No perfect, no GCF. All right, never mind. All right, so what do we have here? M and M. Perfect square for 100. 10 and 10 plus and minus. What about 3? Any GCF for 16 and 25? Any GCF? No. Okay, but ready? What do you know about 16? N squared and 25. Okay, here you go. Yes.